Okay, I've got to prove this one, the first question I'm going to look at. So tan is sine over cos. And sec, remember the third letter in tells you what it's over. So it's over cos. Plus 1 over 1 add sine A. So I'm not really sure what I'm doing just yet with that. So I'll just keep working with the left hand side at the minute. Cos squared A plus 1 over 1 add sine A. Cos squared I want to keep because sec is 1 over cos squared. So I want to keep this, but I really want to do something with this one. Okay, what I am thinking here, if I take this one and if I write that, think of the difference of two squares. So 1 minus sine squared A. That is 1 minus sine A and 1 plus sine A. The reason I'm thinking of that because then that would give me cos squared plus sine squared equals 1. So I'm sort of thinking along those lines because cos squared is 1 minus sine squared. So I could say that cos squared is 1 minus sine squared A, which is the difference of two squares I've already mentioned. So I want this to look like this. So I've already got this factor. I'm going to multiply this fraction by 1 minus sine squared, or 1 minus sine A. So as long as you do it to top and bottom, you haven't changed. And I can now see a path out of this. Because on the top, that there multiplies back to give me cos squared. So I've effectively made the bottoms the same. And if I just add the tops, sine A plus 1 minus sine A, I'm left with 1. And 1 over cos squared is sec squared. Okay, this one here. Now if you look to the link up above, tan sec plus this. That's identical to above. So I could write those bits as sec squared, only your A is 2x dx. Then I've got these wee fiddly bits. So 3, 1 minus 1 over x plus e to the 2x. Tan goes to sec squared, so you'll just go back to tan. But you must have the derivative in front. The derivative is 2, so balance outside with a half. So it's a half tan 2x. Derivative of the bottom is on top, so just log the bottom. To integrate an e, you must have the derivative in front, balance outside, so it's half e to the 2x plus c. Now, we're going to, in the same year, we're going to look at the C4 paper, and we're going to start off with question 3. So, partial fractions. So let's sort out the tops. This one needs 2 minus x, and this one needs an x. So putting x to be 2, that disappears, giving you 2b. So b is 2. Put x to be 0, so you're left with 2a, and that one disappears. So a is 2. So my wee expression can be written as a over x plus b over 2 minus x. I'm going to integrate this. Do you have the derivative at the bottom and the top? No. So start thinking of partial fractions. Before you start thinking of partial fractions, you have to factorise it. And that just happens to be what you have the expression above. So it's the integral of 2 over x plus 2 minus x dx. Now I like to split them up. So it's 2, 1 over x dx plus 2, 1 over 2 minus x dx. Derivative is on top, so just log the bottom. Derivative is a minus, so just balance it. So it's plus and minus is a minus 2, log the bottom line, plus c. For part B, we're going to be looking at the product rule for integration, as in integration by parts. So u is the easier one, so dv by dx is a harder one. So you differentiate this, and you're going to integrate this one. To integrate an e, the derivative must be in front, balance outside. So whenever you integrate it back, the derivative just disappears. So your formula is uv minus v du by dx dx. So it's u, v, just going to pop the third in front, minus v du by dx is just a 1. So before I start this, I'm just going to make it a wee bit easier for myself, bringing that third out. Now, to integrate this, I must have 3 in front, so balance outside with a third. So it's a third e 3x minus a ninth e 3x, and don't forget your c. And I have another question to do with this paper here. We're finding the volume. So volume is pi, you're going between 0 and 4, and it's of y squared. So 2 root x plus 1 squared dx. So square the first, so it's 4x, square the last, and double the product. So it's plus 1 times 2 is 2, double it, and then you've got your x. Now that there is not too bad to integrate, so I'll not bother splitting it up, we'll just go straight for the integration. Add 1, divide by it, x reappears. Add 1, divide by it, so I'm multiplying it by 2/3, and your limits are 4 and 0. So you have pi 2 times 16 is 32, plus 4, plus 8 over 3 times the square root of 4 is 2, and 2 cubed is 8. Take away the zeros. And if you put that into your calculator, hopefully you get 172 pi over 3. Or you could write that as 57 1/3 pi units squared.